Hello, everybody. Today I am going to be showing some cool stuffs on a game, about a game called Tower of Hanoi. Okay, in this video, I'm going to show us the objectives, the definition of the games, how it was invented, and the rule of the games. Okay, and the number of moves. I'm going to prove it. I'm going to prove by principle of recurrence relation or recursion that the number of moves required in this game is 2 to the n minus 1, where n equals the number of discs. Okay, now I'm going to show us the meaning of the game right now. So the Tower of Hanoi. Now I'm checking up, looking up the definition from Wikipedia. The Tower of Hanoi is a game. As you can see right there, it's also called the problem of Benares Temple or Tower of Brahma or Lucas Tower. And it's sometimes pluralized as towers or simply pyramid puzzle. It's actually a mathematical game, a puzzle consisting of 3 rods. That is the initial invention. The game started with 3 rods. Rod, as you can see right here, 3 rods. Okay, and a number of discs of various parameters. For the 3 rods, you have the origin rod, the middle rod, which is the auxiliary rod or pole. You can call it rod or pole. And then the last rod is the destination rod or the destination pole. So it's a mathematical game or puzzle consisting of 3 rods and a number of discs of various diameters, which can slide onto any rod. The puzzle begins with the disc stacked on one rod in order of decreasing size. The smallest at the top. Okay, it has to be in what? Ascending order of size. You cannot do descending order. The disc must be arranged like a pyramid from the smallest to the largest diameter. Okay, so the puzzle begins with the disc stacked on just one rod in order of decreasing size, the smallest at the top, thus approximating a conical shape. Now, the objective of the puzzle is to move the entire stack of disc from the origin rod, okay, to destination rod, to the last rod. Now, and these are the rules of the games. Only one rod, only one disc may be moved at a time. Each move consists of taking the upper disc, from one of the stacks, and placing it on top of another stack or on an empty rod. And be careful, no disc may be placed on top of a disc that is smaller than it. So you cannot place a larger disc on a smaller disc. So when you have 3 rods and 3 discs, the puzzle can be solved in 7 moves. So the minimum number of moves that is required to solve the Tower of Hanoi with 3 rods, 3 discs is what? 2 to the 3 minus 1, which is 8 minus 1, which is 7. So the minimum number of puzzles is what? 2 to the n minus 1. So I'm going to be showing how to prove that. Okay? How to prove that. So let's watch this video. You can see with 3 rods, 3 discs. Yeah, that is the move. Again, let me start all over again. Ring solution, Tower of Hanoi. Look at the way the disc, which is being moved, one disc at a time. let's go to okay, now you've seen the nature of the game. Okay, so you have all these sticks. Now, look at the way it's arranged from the smallest disc to the largest one. And you want to move this disc onto the last rod, and by following the rule of the game. If you have one disc, the number of moves is going to be 1. Very straightforward. And if you have 2 discs, the number of moves is going to be 3. These are the easiest ones. But if you have 3 discs, the number of moves is going to be 8 minus 1, which is 7. Okay. Now, generally speaking, if you have n discs, show that the number of moves required to complete the game is 2 to the n minus 1. Okay, now let's see how to do that. Now, when you look at the nature of the game, you will discover that it satisfies the following recurrence relation. Recurrence relation. Next move, it's twice previous moves plus 1. I'm going to tell you why. When you have one disc, the number of moves is 1. Just one move. If you have 2 discs, the number of moves is what? 3. So 2 times 1 plus 1. See? Twice 2 times 1 plus 1 is going to give you 3. And if you have 3 discs, the number of moves is going to be what? 7, which is 2 times 3 plus 1. So generally, the next move, the next move is going to be what? Twice the previous moves plus 1. That is a recurrence relation describing the Tower of Hanoi. And with the initial condition that when you have 1 disc, the number of moves is what? 1. Okay, so let's use iterative method. Iterative method, right? Now, this is very, very important. These two, very, very important. This formula and this formula. This is a recurrence relation. You can see that T at the left side is defined in terms of T at the right side. So it's a recurrence relation. Okay, now let's, T1 it's 1, but Tn is twice previous one plus 1. So that means T2 is going to be twice of T1, twice of T1 plus 1. Okay? And I know that my T1 is 1. So I have my T2 to be 2 times 1 plus 1. So you have your T2 to be 2 plus 1. Now, when you are doing the proofs, do not add up 2 and 3, 2 and 1 to get 3. No, just leave it this way. Now, similarly, T3 is going to be what? Twice T2 plus 1. Remember, next is going to be what? Twice previous plus 1. That means T3 is going to be 2 into, this is my T2, 2 plus 1, then plus this one. And that is 2 squared plus 2, 1, plus 1. Now this one can be written as 2 to the 0. This is T3. If you do T4, you will get the same thing. Let's try T4. T4 is going to be twice T3 plus 1, okay? Which is twice, this is my T3, 2 squared plus 2, 1, plus 2, 0, plus 1. And that makes your T4 to be 2, 3, plus 2, 2, plus 2, 1, plus 2 raised to the power 0. 1 is always 2 raised to the power 0. See, 2 outside here times 2 to the 2 will give me 2 to the 3. And 2 outside here times 2 to the 1 will give me 2 to the 2. You see that? And this 2 outside here times 2 to the 0 will give me 2 to the 1. And there is 1 already here, which is going to be 2 to the 0. I'm trying to make everything in what? Powers of 2. So you can see that your T4 is 2 to the 3 plus 2 to the 2 plus 2 to the 1 plus 2 to the 0. And if you go on in that trend, when you have 4 here, the highest power at the right side is 4 minus 1, which is 3. 4, 3. See, when I have 3 here, the power is 2. See that pattern? So if you have n here, the highest power at the right side is going to be what? 2n minus 1. Next to 2n minus 1, to the left of it, is 2n minus 2. And you go on that way until 2 to the 0, which is the last one. Remember, I am representing this plus 1. This plus 1 here as 2 to the 0. The reason is because I have others as powers of 2. So I do not want the 1 to be separate. So just make it, I made it 2 to the 0. Okay? Now, this is a geometric series. Series is when you add a sequence together. Series involves the use of plus sign. 2 plus 4 plus 5 plus 6 is a series. So this is a geometric series. And it has first term A to be what? 2 to the 0, which is 1. This is the first time. You can start from ascending order. Okay, make it 2. If you like, I can start from descending. But for this case, I'm starting from the smallest one here, which is 1. Now, any expression of this form has a common ratio. A common ratio R equals to 2, which is the base of the expression. All the time, when you have an exponential expression in a series, the common ratio is going to be the base of the expression. And the base here is 2. So, and the sum of GP is given as A into R to the n minus 1 over R minus 1. Where A here is the first term. R here is the common ratio. Here is the number of terms. Now here in the Tower of Hanoi game, and our hand represents number of discs. Number of discs. So coming back here, I've got sum to be first time is what? First time is 2 to the 1, which is 1. 1 into common ratio is 2. The common ratio is 2. 2 to the n minus 1 over 2 minus 1. Common ratio is 2. And that sum is what? 2 to the n minus 1. That is the sum. Remember, and I'm representing the sum as Tn. So the sum is just Tn. This Tn, it's in relation to what? Recurrent relation. So 2 to the n minus 1. So the number of moves required for a tour of Hanoi game with n discs is 2 to the n minus 1. So if you have 10 discs, it's going to take you t equals 2 to the 10, which is 1024 minus 1, which is 1023. This will take a while to complete. So you have to start moving this disc like 1203 times to complete the games. Now, if you imagine when your n is 50 discs, you will almost be doing it forever. 2 to the 50 minus 1. I don't think I can do that. Okay? So that is the proof. In a tour of Hanoi game, the number of moves is 2 to the n minus 1, where n is the number of discs according to the game. Once again, look at the game. This is the game. It has a number of discs arranged on one pole in the ascending order of disc diameter. The smallest one is at the top. And when you move the game, you want to move from pole A to pole C. But you have 3 poles, not 5 poles, not 2 poles, 3 rods. Okay, you can make use of the middle as an auxiliary pole while moving, and you cannot move 2 discs at a time. And you cannot place a larger disc on a smaller disc. So if you have this game, and if you have 5 discs, no matter how smart you are, you will require 2 to the 5 minus 1 moves, which is 31 moves. That's a lot of work. Now, for these minimum moves, the minimum moves is 2 to the n minus 1. It's for those who know how to play the game. If you don't know how to play the game, you can play the game forever. I hope this is very informative. Thanks for watching.